Testing? Testing? Okay, welcome to the video. The example we're looking at here is how to calculate the maximum weight capacity an elevator should have. You see these signs in elevators when you ride in them all the time, so here's an example of some calculations that might be done involving that number you see in the elevator. So this is in a 20-story high-rise, and we know that the people who work in this building have weights that are normally distributed according to their gender. So for women working for the company, the average weight is 143 pounds with standard deviation 29 pounds. And for men, it's 183 pounds with standard deviation 24 pounds. Now when we design this elevator, it needs to be able to carry 13 people. And since the males who work in this building tend to have a heavier weight, have an average weight, we'll assume that it needs to be built so that it could carry the worst case scenario of sort of the heaviest case scenario of 13 men. So with that in mind, notice we can eliminate some of the information that was given to us in the problem. We're not going to need to even use this information about women. So let's go ahead and just kind of, if I can get my pen to work, just say we don't even need that information. Here's what we need, that men's weights are normally distributed with this mean and that standard deviation. So we can say men's weight, just to kind of summarize our important information, is distributed normally with mean 183 and standard deviation 24. Now we're talking about a group of 13 men, right? So we're going to have 13 people on average, or 13 people in that elevator at max capacity. So let's take a look in a group of 13. So that 13, that's going to be our n. That's our sample size there. N equals 13. A group of 13 men. The average weight we can use the notation x bar. That's also going to be normally distributed with the same mean, 183, but our standard deviation will decrease, right? It's going to be the population standard deviation of 24 divided by the square root of the sample size, which was 13. And if you're curious to see what that is, 24 divided by square root of 13 gives me about 6.7 if I round. So standard deviation 6.7 pounds. Alright, so this is the distribution that's going to be helpful with us because we're going to assume there's 13 people in that elevator. So let's draw out that distribution. Normal curve. There's my mean, 183. And the question that's being asked here, they're saying they want the maximal total allowable weight. What should that be? If we want the probability to be 0.995, that it will not be exceeded. So if we think about our distribution here, we want to find a number on this distribution somewhere out here such that the area to the left of it is that 0.995. So this area equals 0.995. Oh, I got an extra 9 in there. Sorry, let's erase one of those 9s. 0.995. Because if we think about the picture, that means that for every group of 13 men that enter, the average weight would be below that value 99.5% of the time. Alright, so let's remember our calculator commands. If we know an area and we're looking for a value of interest, we can use the inverse norm calculator command to find that value. So inverse norm always wants the area to the left of the value of interest, which is what we have. That area is 0.995. The mean of the distribution is 183, and we're talking about the group of 13 men, so the standard deviation is 24 divided by the square root of 13. So let's put that in our calculator. We'll do second vars and choose option 3 for inverse norm, and then type in 0.995, 183, and then 24 divided by the square root of 13. When we do that out, we get 200 point, I'm getting 14575. I'm going to leave that in my calculator unrounded because I'm not done yet, right? This would be the average weight of the group of men. So what this is saying is if there's 13 men in the elevator, 99.5% of the time, the average weight of that group will be 200 pounds or less. So let's fill that in the picture just so we can say that's 200 pounds or less. But we want to know the maximum weight. When you get in an elevator, the sign doesn't say the average weight of your group needs to be less than 200 pounds per person. The sign says the total weight of this group needs to be less than so many pounds. So if this is the average weight per person, what would be the total weight for the group? So we could say, so for 13 people, so the weight of 13 people will be 13 times that 200.14575. So if I go ahead and do times 13, the number I get there, 2,601.89 pounds. So we can round that up. I think they ask for it in whole numbers, right? Round it to the nearest pound. So that would be 2,600 would be the maximum weight capacity, or the maximum weight for that elevator. And 99.5% of the time, the people who get in that elevator would be below that weight. And actually not the people who, but 99.5% of the time, when the elevator is full with only men, the weight will be less than that.